So what we're going to do is I want to help you review a little about nomenclature, because we are going to have some nomenclature problems on the exam as well as homework 3, because last semester, especially if you had me, I don't know about what happened in Dr. Bay's course or section, but I only required up to alcohols. So now this first exam, you're going to be required to understand up through aldehydes. And so we're going to review a little bit about nomenclature. Now, let's talk a little bit about the anatomy of the name. At least that's what I call it. So, there's a name in IUPAC nomenclature. And the name has very distinct regions. So at the very beginning is the stereochemistry. Then comes the substituents. So the substituents is where pretty much most of the pieces of the molecule that are dangling off of the parent structure, that's where you're going to place their names, as well as the locants that tell you where on the parent structure or parent chain of carbons they're located. Then comes the parent. So that's the name, or I should say that's the piece of the name where you've got that's based on the number of carbons that are in the longest chain, whether it's 1 carbon and it's meth, or whether it's 10 carbons and it's deca, but that's based on the number of carbons in the longest chain. Then comes the unsaturation. So this is essentially in the name, say for example like pentane or pentene or pentyne, which is based on how many, or I should say whether there's all single bonds or the presence of a double bond or the presence of a triple bond. That's what goes here. So whether it's AN, EN, or YN. And we'll delve into this as we do some examples. That's where this goes. And then the end is what is just called the functional group, but really it's the priority functional group, because we're going to find that some functional groups will be listed in the substituents because they're not the high priority functional group. You always look through the molecule and identify which functional groups are present, and then also which one is the highest priority functional group in the molecule. And at the beginning, right here, the stereo, that's where you write the stereochemistry that's involved in the molecule. Now, for me, in my section, I choose to make that more extra credit because that was really the focus of Organic Chemistry 1. Now, because of that, you should still be able to do it, but because it's not the main focus here in OCHEM 2 specifically, I tend to make that more extra credit. So if you're still able to do stereochemistry determination for RS, or EZ for double bonds, that's where you can prove that to me and obtain perhaps some extra credit in the nomenclature problem. So I'll go ahead and post these tables in our Blackboard site. These are just some tables that are from the textbook that help you with nomenclature. Being that our exams are open notes, these are things you can use as you try to answer the nomenclature name problems. The biggest challenge now will be, being able to use the rules, as I'm going to give us some examples of here on how they work. But, you don't have to do any memorization this semester. So if you want to know what the parent name is for 1 carbon, there it is, meth. 5 carbons, pent. 9 carbons, non. And this right here is a list of kind of the basic names that come about when you don't have a functional group that changes the suffix or ending of the parent name. So, if you have just a chain of 5 carbons, it's called pentane. Now, we do change this part based on the unsaturation, and we change the E if there is a higher priority functional group. Now, right here, we're looking at the functional groups that are common in organic chemistry. And one thing that it says in the title, it's kind of a long title, but you just have to realize, I'll draw an arrow right here, that just shows you what the title's trying to tell you is these are in order of priority. So that is to say, if you know that you have a nitrile and an aldehyde in your compound, then it is the nitrile that will be used as the suffix, and it is the aldehyde that will be treated as a substituent. And how do you name them then? Is the suffix is if it's the highest priority functional group, and this goes at the end of the name. And if it's going to be treated as a substituent, you use this name in the substituent section. Now for us, we're going to stop for our exam 1 at aldehydes, and so because of that, there's not ever going to be in exam 1 a functional group that is higher than aldehyde, so you're never going to use it, or name it I should say, any aldehydes in your molecule as a substituent. So you're not going to use the oxo, at least in terms of aldehydes, as a substituent name. You're always going to, if there's an aldehyde, you're going to always use the suffix because it'll be the highest priority functional group if it's there, because we're not going to use any of these in exam 1. Now, if it's a ketone and an aldehyde, then the aldehyde, again, being the higher priority, will get the al as the suffix. It'll change the end of the name to al, and the ketone will be named as a substituent in the substituent section. But let's go ahead and let's do an example. So let's take a look at this molecule. Once again, the key to doing a nomenclature is you have to kind of take it in stages. So one of the first things you have to do is you have to find the longest chain of carbons. But at the same time, it's kind of weird. You kind of have to simultaneously keep some other things in mind. So you also have to look for the highest priority functional group. And so hopefully you realize right here, here's an aldehyde. So right there, that is going to be the highest priority functional group. It's going to be called al. And because this is right here on the 1 carbon, in fact, aldehydes are always on the 1 carbon, so you never have to put a locant for them, unlike other functional groups that can oftentimes be found at different positions in the chain of carbons. So you don't have to put 1 al. I won't mark you down if you do, it's just not necessary. Now, once you find the highest priority functional group, that must be in the longest chain. So even though you might be able to find a longer chain somewhere in the molecule, if it doesn't contain the highest priority functional group, it doesn't count. So you always have to make sure you know where that functional group is, if there is one that's has a priority. So right now, here it is. So we have to start here, or end here, depending on how you're thinking about it. The other thing the students oftentimes make the mistake of is they think they can just stop mid-chain. You can't. You have to go to the end of the chain as long as it's still linear. So when I'm counting, I can't just go 1, 2, 3, 4. Okay, I'm going to call it butane, or well, whatever else I would change it based on the groups. No, I have to go 1, 2, 3, 4, 5, 6, 7. I have to go to the end. And then if there's any branching, I have to explore those branches and see, is there any other longer chain? Now, this one is pretty simple. There's only 1 branch you have to consider, and they're the same length. And so at that point, it is going to be a 7-carbon chain. 1, 2, 3, 4, 5, 6, 7. So that means the parent name is hept, and that's in that chart right here. 7 carbons, hept. So knowing that, what that means is this, it doesn't really matter which one because they're kind of the same piece. This is the extra thing that's dangling off the main chain. So that is a substituent. This is a substituent. And this is a substituent. Not this carbon. This carbon is part of the main chain. So it's really this oxygen that's being double bonded to it that's the substituent. And that's why, unsurprisingly, if you look at the chart here, this is a ketone. So normally this would be called a ketone. You would think it would be, change the ending to ONE, but it's not the highest priority functional group. That's the aldehyde. So we look at ketones, and we see that when they're treated as a substituent, they're called oxo. So this is an oxo group, very much like this chlorine is a chloro group. So now we pretty much identified everything. All these carbons are part of the main chain. These 2 things are substituents. This is a substituent, and this is the highest priority functional group. So right now, the other thing is unsaturation. There is none. Outside of the double bonded O's, there's no carbon-carbon double bonds. There's no carbon-carbon triple bonds. So we still put AN. If there was a double bond, we would put EN. If there's a triple bond, YN. And we'd have to locant it. That is, put a number where it is located in the chain. But there isn't. And we don't put an E because this has functional groups in it. It has an aldehyde, so it becomes AL. So this is heptanal. the chain. And then it's got these 3 substituents connected to heptanal. And we have to number it. Now remember, numbering pretty much, especially in linear molecules, is pretty straightforward. You only number it one direction or the other direction. So it's either 1, 2, 3, 4, 5, 6, 7, or it's 1, 2, 3, 4, 5, 6, 7. And the first rule that you always go for, and that's what's going to determine it here, is the fact that this is the highest priority functional group. And if you numbered it the other direction, this would be at the 7 spot. By numbering it 1, 2, 3, 4, 5, 6, 7, this is at the number 1 spot. And that's what you want the highest priority functional group to be at, is the lowest locant number. Now that's not the only decision to be made, because sometimes which direction you number things, and then rings out a whole other set of issues. Which direction you number the main chain can sometimes be multiple options where they both have the lowest number possible for the highest priority functional group. By the way, this is where students sometimes want to shorten the chain, because they're like, oh, if I go any further, that would actually number it with a larger number. But that's okay. You have to find the longest chain. The only time you begin to think about how do I minimize the locant value of my functional group is simply saying, do I start from this end or do I start from this end when numbering my chain? So now what we're going to do is we're going to say this is 1, 2, 3, 4, 5, and then 6, 7. I mean, I'm not going to draw those numbers because they're not needed for anything, except, they are. I'll just draw them. 2, 3, 4, 5, 6, 7. So now these are the substituents that we need to number now. So this oxo is at the number 3 carbon. This, and I didn't name this is 2 carbons, so it's ethyl. It is located at the number 5 carbon, and this chloro is located at the number 5. So that means this is 3 oxo, this is 5 ethyl, and this is 5 chloro. Now, what order do we put them in? It's not numerical, it's alphabetical. So it's O, E, C. And so this right here, we do it C first, then E, then O. So it becomes 5 chloro, and then 5 ethyl, and then 3 oxo, and then finally the name that we figured out for the parent name is hept, and then an, because there's no unsaturation, and then al. And there is no stereochemistry in this example, so we don't have any stereochemistry at the beginning. So this is 5 chloro, 5 ethyl, 3 oxo, heptanal. Example I decided to do is a little bit more challenging. This is something you sometimes don't always realize. Students oftentimes make this mistake. When you're dealing with a cyclic structure and a linear portion on a molecule, you cannot call the longest chain one that bleeds into the ring. In other words, you can't say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or anything like that. Whenever you have a linear portion and a cyclic portion, you have to say it's either a cyclic parent name or it's a linear parent name. And how you determine that is based on, well, which one is the longest chain, but first and foremost, which one contains the highest priority functional group. And in this case, it is the linear portion that contains the highest priority functional group, the ketone. So right here, this is the ketone. And so what that means is you're going to number it 1, 2, 3, 4, and then 5. So it is a 5 carbon chain with a methyl substituent and OH substituent. And this, even though it looks like a too big to be one, it is a substituent. And so what would this normally be called? It's 6 carbons in a ring, so it would normally be called cyclohexane. And so just like methane turns into methyl when it's a functional group, so this is a methyl group, cyclohexane becomes a cyclohexyl group. So now that we've identified all our substituents and we've numbered our longest chain and we've found the highest priority functional group, let's double check our numbering. So we could easily number this from 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5 and have this be the number 4 carbon, but it's actually better that it's the number 2 carbon. So that's what we're going to stick with. So this number, the locate numbering is correct now. We have all the substituents labeled and figured out. And so it's a 5-carbon chain, so it would be pent. So what is OH? Let's double check our list here. Alcohols are called hydroxy when they're a substituent. So this is a hydroxy group. This is a methyl. This is a cyclohexyl. So there's no unsaturation, so it ends in AN. And there is the highest priority functional group is a ketone, so it ends in pentanone. So once we now know this is the main parent name, now we got to lay out our substituents. This is at the number 4, so this is 4-methyl. This is at the number 3 carbon, so this is 3-hydroxy. This is at the number 4 carbon, so it's 4-cyclohexyl. But remember the numbers that we do need to list them or know them to put them in the name. That doesn't determine the order; it's alphabetical. Now, unlike when you use multiple substituents, or when you have multiple substituents in your structure, and you have to use di or tri to represent there being more than one of them, like if there's 2 chlorines, it would be dichloro. You don't alphabetize by the di, by the D, only the chloro. But cyclo is actually part of the name. So you don't alphabetize by the H, you do alphabetize by the C here. And so this becomes, we start first with 4-cyclohexyl. And then the next one is the H, so 3-hydroxy. And then finally 4-methyl. And then pentanone. 4-pentanone. Now that we have that all written out, we do have actually stereochemistry. So we have the highest. Now we have to switch the terms of priority. We're now talking about CIP, ranking. So the hydrogen, if you remember, this is extra. This will usually be extra credit. This is the lowest priority or lowest ranking of the CIP numbering or ranking, from stereochemistry. So that's a number 4 group. This right here is a carbon with a bunch of carbons connected to it. This is a carbon with an oxygen carbon connected to it. This one has 3 carbons connected to it. And this is an oxygen. So this is, of course, the first ranking of CIP. These two are, both carbons, so we can't really choose between them based on what they are. O and H are obvious, but 2 carbons, they're identical. But then we notice that this carbon has 3 other carbons connected to it. But this carbon has 2 oxygens. Remember, double bonds count as if the atom is connected twice for CIP. This has 2 oxygens and a carbon. So this gets the number 2 ranking, and this gets the number 3 ranking. Remember, these aren't locants. These are rankings for CIP rule. And this is where, depending on on how you like it, you can do counterclockwise, clockwise, where's the H, is it dash or wedge? I just simply do this. It's going into the page. That's what dash means. So I put my thumb into the page for both my hands. Which one of my hands curls 1, 2, 3? My right hand curls 3, 2, 1. So if I put my thumb down, it curls 3, 2, 1. But if I put my left hand with the thumb down, it curls 1, 2, 3, my hand. So it's my left hand with the thumb down because I'm pointing my thumb in the direction of the hydrogen, or that is to say, whatever is the number 4 ranking. I'm putting it down, and as I curl my hand, it goes 1, 2, 3. That means my left hand is correct. Left hand always means S. So this has an S. Stereochemistry. Now, you don't have to number it unless there's multiple stereochemistry sites. There's only one in this molecule. So that's how you name this example. These examples were helpful. We will do some in our worksheets for our breakout sessions, and we'll talk a little bit in class, as well as continue our discussion on aromaticity, especially when heteroatoms, that is oxygen, nitrogen, things that aren't carbon, are located in the ring system. And then we have to still determine whether it's aromatic, anti-aromatic, or non-aromatic. And it has a lot to do with them having lone pairs and whether or not those lone pairs are involved in the ring system, the ring pi system. Anyways, see you in lecture.